So here we are at chapter 8, and chapter 8 deals with exponents. So we did a little bit with exponents in chapter 1, and we've seen them here and there, but this chapter is really going to get deep into them. So 8.1 starts out with products and powers of exponents. So let's just take a look at a little lesson opener. So first of all, we need to remember that when we have a like base, like we have x's, so it's a like base, and we're multiplying with exponents, that means we just add the exponents. So we would have x to the third plus 2 for this x squared, and we end up with x to the fifth. So same thing here, we have like bases. We have negative x's, so we're going to keep a negative x. We have 2 plus 3, since we're multiplying with exponents, we add those exponents, and we end up with negative x to the fifth. Whenever we are taking a power to a power, that's when we go ahead and multiply. So this would be like y times 2 times, or y to the second times 5, which would be y to the 10th. And then when we have coefficients out in front of our terms, first of all, remember there's always an imaginary 1 here. This means we're multiplying these, so we've got a y to the 1 plus 1. And then we have to multiply our coefficients also. So we have 2 times 3 out in front, times y to the 1 plus 1. 1 plus 1 is 2, and 2 times 3 is 6. We end up with 6 times y to the second power. And then for this one, we do have like bases, so we're just adding our exponents since we were multiplying those like bases. We end up with x to the a plus b, and we can't simplify it anymore until we have values for a and b, so you would just actually leave it, x to the a plus b power. So for our properties of exponents, same as they were before, but let's just review them. So the product property says to multiply powers with like bases, add the exponents. Then we have the power property, which says to raise a power to a power, we multiply the exponents. So let's look at example 1. In 1a, we are adding exponents. So we start out with x to the fifth times x to the second. Just like we just did in that warm-up, we're just adding the 5 and the 2 for our exponents, and we end up with x to the 7th. B says multiply the exponents, so we start out with x to the 5th taken to the second power, so we just multiply that 5 times 2 and get x to the 10th power. And 1c, it says remember the order of operations. Raising 2 powers comes before multiplication. So we start off with y to the 4th times y to the 3rd, which is taken to the second power. So we're going to have to start off with our power of our exponents first. We'll do our multiplication because of our power property. So 3 times 2 will be 6. So we end up with y to the 4th times y to the 6th. And then we can go ahead and use our product property, and we can add those, and we end up with y to the 10th power. For example 2, it says you can apply the commutative and associative properties of multiplication. So example 2 starts us off with 3x squared times 5x. So this is our beginning problem here. And we're just saying, well, I know I'm going to have to multiply my 3 times my 5. And then I have an x to the second and an x to the first. I'm going to have to multiply those, and to multiply those I'm going to be adding my exponents. So we're adding our exponents here. So we have 3 times 5 is going to be 15, and x to the 2 plus 1, that's 3, so it's x to the third. So 15 times x to the third. So we just need to always remember that anytime we see an x, there's actually an imaginary 1 after it, or any variable. It's automatically taken to the first power. So example 3. We keep doing the same things. These just keep getting a little bit more complicated. We just need to unpack them a little bit further. So first things first, we want to see what digits we're working with here. So we have a negative 8, and that's it. So we'll have the negative 8. Then what kind of x's do we have? Well, we have an x to the second power and a plain old x. So we'll put those together. Then we'll have our y's, and then we'll have our z's. which we have a third power and a second power. And we just kind of group those all together with the like bases. So we'll have an x squared times an x, a y times a y, and a z to the third times z to the second. And then since we're multiplying with those exponents, we're going to be adding the exponents. Remember, there's always a 1 here. So we have negative 8 times x to the second plus 1, y times y to the 1 plus 1, and times z to the 3 plus 2. And then we can just add those exponents. And that would be our final answer. So this is in simplified form. For example 4, where you need to go ahead and simplify, well, what are we doing here? What does this actually look like? If we are taking this whole thing to the third power, that's like multiplying that whole thing 3 times. So we need to go ahead and write it out. Like we're multiplying that all 3 times. And then what do we end up with? Well, think about it. If we have a negative sign, that means there's an imaginary 1 there. So it's negative 1. So we have a negative 1 times a negative 1 times a negative 1. And then we have 3 a's and 3 b's. Or sorry, 3 b squareds. And then we can go ahead and combine. So negative 1 times negative 1 times negative 1 gives us a negative 1. Anytime there's an odd number of negatives, we always end up with a negative answer. 3 a's would be a to the third power. And 3b to the seconds would be b to the second plus b to the second would be b to the sixth. So we end up with, we can go ahead and drop that 1, so negative 1, or negative a to the third times b to the sixth. So properties of exponents. The commutative and associative properties can be used to show that the power of a product is equal to the product of the powers. So we have the quantity of a times b times c, all taken to the nth power, is equal to a to the nth times b to the nth times c to the nth. So example 5. What that's telling us is we're basically going to apply our power to each item in our parentheses. And the same thing over here with the second. So now we have negative 2 to the third power, n to the fourth taken to the third power, n to the third power, times 1/6 squared, m squared, and n to the second squared. So remember, anytime we have a negative inside of the parentheses, it's like saying negative 2 times negative 2 times negative 2, and that will give us a negative 8. So then we have m to the fourth taken to the third, so we're going to have to multiply these two things. That'll give us m to the 12th, and then n to the third will stay the same. This is like 1 to the 6th times 1 to the 6th. 1 times 1 is 1. 6 times 6 is 36. M squared, that's good, and then we'll have to multiply these two things. We'll end up with n to the 4th. Okay, so this is what we just said we had. And then we can go ahead and simplify it a bit farther because we still have m's left. We still have plain old coefficients. We still have n's left. So we can rearrange them, which is what they've done in this step. We can say negative 8 times 1 over 36 is negative 2 to the 9th. Our m's combined give us m to the 14th, and our n's combined give us n to the 7th. So this actually ends up being our final answer when we're simplifying. And then last but not least, example 6. So we're simplifying, again, it says first simplify each term. So the first thing we notice is that there are more than one x in our first group here. So we have an x squared, and an x. So we can combine those. We'll end up with x to the third y squared. And then here we have more than one x also, so it'll end up being 3x to the third y. And then we're good after that. So we can go ahead, this is what it looks like once we've simplified each term. So this term has been simplified, this term has been simplified. Then we can go ahead and combine our like terms. So, if you think way back to chapter 1, when we had like terms, they were identical. We have x to the third, y to the second, and x to the third, y to the second. That means there's like a 1 here, so we're saying 1 x to the third, y to the second, minus 5 x to the third, y to the second. So we end up with negative 4 x to the third, y to the second, plus 3x to the third times y. Now, because we're not multiplying here, because we are adding, this is actually as far down as it goes. So we don't go through that whole process of breaking everything apart and then combining it back together when we're adding or subtracting our terms. We only do that when we're multiplying our terms. So that's actually it for this lesson. Go ahead and take a look at your assignment. This is going to be a bit more bookwork than usual, just because we've already done so much with exponents on Khan Academy. But just go ahead and take a look at it and let me know if you have any questions.